Okay, so here, as we take a look at lesson 2 of our moving unit here in robotics, we're going to take a look at proportional relationships, right? A proportion is when two things are related to each other in a certain way and they continue to be that way. So like, let's say 30 miles per hour. So for every hour driven, we go 30 miles. For 2 hours driven, we go 60 miles. It's a linear relationship. So as your robot drives, the rate that it drives is a proportional relationship to how many times the wheels are spinning around. And if we take our wheel here, you can actually calculate exactly how far it's going to go by taking the diameter, that's the distance across the circle, which is the wheel, and the circumference. Now, one thing you should know, if you haven't learned this in math class already, is that there is a relationship between the distance across a circle and the distance around a circle, the diameter and the circumference. And that relationship is pi, which you've probably heard about before, 3.14. But you're like, where did 3.14 come from? Well, it's actually how many times this distance across the circle can go around a circle. So it goes 1, 2, 3 times, but there's still a little bit left. And then that's that 0.14159 non-ending, non-repeating number that goes on forever and ever. That number, 3.14, is the amount of times the diameter goes around a circle. And it's actually pretty cool, and there's a lot to learn about it. But the circumference tells you how far will the robot move for one exact rotation. And if you multiply that distance by the amount of rotations here, that's the total distance the robot will travel. So if the diameter of the small circle is 5.6 centimeters, then the circumference around would be 5.6 centimeters times 3.14. So 3.14 of these would make that circle. And if you calculate that yourself, it would be 17.5, right? Now, we know that the circumference of the TacoBot, or any robot you build with the LEGO Spike Prime, is 17.5. So if you take the amount of rotations that you code it to do, well, then you'll get the total distance traveled. So in this example here, we have 17.5, the distance, the circumference around the circle, times 3 full rotations, which means that the robot will travel for 52.5 centimeters. So what about, here's an example of it traveling 3. You can see this arrow as you look. It does 3 full rotations, which get it here to 52.5 centimeters. Now your question is, how far will it travel with 12 rotations? Now think, 1 rotation is 17.5 centimeters. You're going to need to figure it out for 12 rotations. So go ahead and solve that now. You can go ahead and open up a new tab and get up in Google Calculator. Now, go ahead and check your work here. So you have the 5.6, which is the diameter. You times that by 3.14, getting you the circumference. Now, you might have already taken that number. 17.5 centimeters times 12 rotations should give you 210 centimeters. And that will be its total distance traveled. Now, when you're coding your robot, you can figure out exactly how far to go by its centimeters, by its rotations.